Okay, let us start a new topic today, that is quadratic equations. Quadratic equations. What is a quadratic equation? If you need to define it, then you can say an equation with highest power of the unknown as, what do I mean is, let us say this should be an equation first of all, and highest power of the unknown, or you can say variable, is 2. For example, if I write 2x square plus, let us say, 5x plus 7 equals 0. Now this is an equation because there is an equality here, and highest power of the unknown, that is x in this case, is 2, right? So this is a quadratic equation. And you can write another example, let us say 5. You can replace x with anything else also. Let us write 5y square plus 3y plus 2 equals 0. This is another quadratic equation in y. In this case, the unknown is y, right? And the highest power of y in this case is 2. And it is equation because this involves an inequality. This involves an equality in it. Okay. Now, on the right hand side of equality, you can have other things also. You may not have 0. You may have, let us say, let me write 3z square plus 5z plus 1 equals 5. This is also a quadratic equation, right? Let me write something else. 3t square plus 5t plus 3 equals 5t plus 3. This is another quadratic equation, because if you bring all of these terms to the left hand side, what will happen is you will still have the highest power of unknown, that is t in this case, as 2, right? And you will still have the equal sign in this equation. So an equation with highest power of the unknown as 2 is known as quadratic equation. Another way of looking at it is, we have studied about polynomials, right? If we have a quadratic expression, if we have a quadratic polynomial expression, and we equate it to 0 or some other constant or some linear, okay, for the moment you consider that you equate it to 0, right? You equate it with something that doesn't change the fact that highest power of the variable is 2, then this will be known as quadratic equation. For example, we studied about the quadratic polynomial ax square plus bx plus c. Now if I put it equal to 0, then this will be my quadratic equation, and I just need to take care that a is not equal to 0, because if a becomes 0, then this term will vanish and this will no longer be a quadratic, this will become a linear. If b becomes 0, then it will be some constant, right, equals 0, then c can only be 0 in that case. So based on this also, you have got certain definitions. For example, if let us say b is equal to 0, then you will have ax square plus c equals 0, and this format of quadratic equation is known as pure quadratic equation, right? When you have got coefficient, that means you have got coefficient of linear expression of x, or you can say coefficient of x as 0. When you have coefficient of x as 0, then this is known as pure quadratic equation. That means you don't have any linear expression of x in this, okay? And another kind of quadratic equation is adfacted or complete quadratic equation. What is adfacted or complete quadratic equation? Where we have got a second degree term, the linear term, the first degree term also, right? These kind of equations, quadratic equations, are known as complete or adfacted quadratic equation, right? In any case, the standard quadratic equation is standard quadratic equation is ax square plus bx plus c equal to 0, where a is non-zero, right? Where a is non-zero. Now, this is an equation. In polynomials, we studied about quadratic expressions, right? Quadratic expressions, we made the graphs of quadratic expressions also, right? And we studied about the minimum and maximum values of those graphs, right? But here, in this case, I've got quadratic equation, and we will talk about the solutions of these quadratic equations, right? And what are the solutions? Such values of x for which this equation is true, right? Such values of x for which this equation is true. That means when I put x equal to that value, the solution, the left hand side will become equal to right hand side. Okay, in this case the left hand side should become 0 at that value. So such values of x for which this equation satisfies is known as the solution, and the another name for these solutions is roots, right? So the values of x that make this equation true or valid, those values are roots of this equation. Okay, okay. So most of the chapter is about finding the roots, okay, and determining the nature of roots, right? And we can also talk about position of roots, etc. at the higher levels. But for now, let us talk about roots in details. First of all, let me clear the board. So if I write the standard quadratic equation once again, ax square plus bx plus c equals 0, where a is not equal to 0, and obviously a, b, c are constants and these are real numbers. Okay, so roots are such values of x. I told you, let us say I take x equal to alpha. Okay, if I put x equal to alpha here, it should satisfy this equation. A alpha square plus b alpha plus c should also be 0 for x equal to alpha to be the root of this quadratic equation. Okay, this is what I mean when I say that the root should satisfy the equation. If I tell you that x equal to beta is the root of this quadratic equation, then you can imply that a beta square plus b beta plus c will be equal to 0. Okay, this is what you should know. Now there are various ways of finding the roots. Let me clear the board. Ways to find the roots. Okay, I will focus on little higher level of things here, but let me just give you a glimpse of certain other methods also. Let us say factorization method. First method is factorization method, that we factorize the given quadratic equation and find the roots. Second way can be completing the square method. I talked about this method in the chapter of polynomials also. And another way can be direct formula, right? So let me first of all talk a little bit about factorization. For example, let us say we have got x square minus 3x plus 2 equal to 0. Okay, when we studied about polynomials, we talked about zeros of a polynomial, right? Zeros of a polynomial. And then we spoke about the product of zeros and sum of zeros, right? So if this quadratic expression has got zeros like alpha and beta, then what is alpha into beta? It is the product of zeros, that is 2 in this case. And what is sum of zeros? It is 3, right? Now to factorize this quadratic equation, I need to split the middle term in such a way that it gives me the product as 2 and it gives me the sum as -3. Okay, let me rephrase it. It should give me the product. Let us say if I split the middle term like this, x square minus 2x minus x plus 2 equal to 0. This equation and this equation both are same equations, right? Now why have I split this term in this form? Because if I add these two terms, right, the sum of these two terms is still minus 3x, right? So I should split this middle term in such a way that the sum is minus 3x and the product is 2 into x square, that is 2x square, right? So I have already done that, so let me do the next step. Now what I'll do is I'll take x common. Okay, so I'll be left with x minus 2, and from here I'll take minus 1 common, so I'll be left with x minus 2 inside and put it equal to 0. So what I can say here is x minus 1 into x minus 2 is equal to 0 is the factorized form of this quadratic equation, right? So now this is the factorized form. What can you say about the roots of this? Because this bracket or this bracket, I've got product of two brackets as 0. So either this has to be 0 or this has to be 0 to make this equation true. So if I put this equal to 0, x minus 1 equals 0, then x will be equal to 1. If I put x minus 2 equal to 0, then x will be equal to 2. So the roots of this equation are 1 or 2, 1 comma 2. So these are the roots of this equation, okay, using the factorization method. Now let me come directly to the next method, completing the square method. This will also involve the formula, because when I go through this method, completing the square method, I'll derive a formula which you can apply directly to solve the quadratic equations also. Okay, so for that let's make another video. Okay.